Hello sir, Assalamualaikum. My name is Charles here. I'll write my name and ID here. Name is Shahid. ID. I need. I need to copy the task one as instructed here. Uh, I will go fine. Okay, so let's go to the column first. Wait, let me change my GSOT account here. Upload my. Okay, so I have to download it. Download the CSV file. Is it recording? Yes. CSV file. This is the CSV file. Okay, I already downloaded it here. So file. Yeah, see. PC upload is RAM. Okay, okay, okay. This is the CSV file. The table I can see here. Now let's just delete everything and start coding. So I'll write my name and ID normally here. Name, my name is sorry, name is register here. ID is 1811 and I'll start the coding. Okay, I'll upload the CSV file. Now I'll start coding as instructed. Instructed. Okay, so where's the this is Kernel, so I have to go to okay from here. Import. At first I have to copy import pandas as PD. Import pandas as PD. And next here. So let's copy the whole thing. Here's vertical. F8. I hope it will run on now. Let's run it. Let me just directly copy it. Okay. It's a bit, but I did the same thing. Why did it one day before? So in here, import pandas is PD. I import the pandas and load the manipulate the data. Next, df equals to PD. In here, the file CSV file here is read into the data frame df. It will read into df, and in the next line, df here. Then rename the column unnamed. This unnamed into time. Time since it likely contain the time data. Then next line, by converting the time column here into date time format, I ensure that the time-based operation works correctly. Next, I have reversed by doing the -1 the data frame rows using ilog. I log minus 1 here. It will reverse the data frame. So the oldest data comes first and you set the time column as the index. Then I have written the tf.head and run. The data set will show here. Next. Uh, wait, this one. Then import matplotlib. I'll copy it. Wait, copy vmp.show code control V. Okay, so it has got the graph here. Okay, so now close.usd here. Close.usd column, which is likely the closing prices in USD using the matplotlib, and this function has brought the graph here. This line graph provides a visual of how the closing prices fluctuate over time. This is like a time period down here. Now we're going to split the data. For that we write that's code for splitting here train.dfm. I'll just copy it. Okay, train.diff I log minus 200 and minus 200. Okay, so your data is split into two sets here. These two sets, a train set and a test set. The train set contains all but the last 200 rows here, and the last set contains the last 200 rows. Same goes for it. This is a common practice actually. Then I guess we run it. Okay, it has run. Machine learning actually in forecasting. I have to train a model on one part of the data and test it on the other to evaluate its performance. It's actually evaluate how it will run, like it will determine the performance. Takes okay. Okay, I'll do the animal part here. From state animal. Okay, I'll just copy code paste more again. I'll just copy everything. Whatever animal and make prediction. Result model. Okay, I'll just run it. Oh, what happened here? Let's just copy everything. In order 210. Model animal. Oh, sorry. Hey, this one. Okay. Model animal. Order 210. I have to write train.close USD. Train.USD order 210. Results model negative field and order remove result for count. I hope it will run. Okay, it is around. Okay, let me explain it. Uh, I imported the array here, the first line. Then in here, for states model dot TSA. So integrator array actually means that auto-regressive integrated moving average. It models from states model library, which is commonly used for time series forecasting. Then I write the model array train.close UST here, order 210. 210 actually means AR, this is AR, this is I, this is MA, 0 is MA. It means the period equals to 2, defines the data, D equals to 1, and no moving average. 0 means no moving average, which is Q equals to 0. Then you feed the model to train.close USD. You have to feed the model here. Train.usd data, you will feed the data close to here. Then after that, I just type the result equals to model.feed. Then I run it. After feeding the model, I need to predict 200 steps per day. So I have written it in this form of this method here. Results of forecast equals to forecast bracket steps equals to 200. Okay, this forecast value represents the model prediction for close UST over the future period actually. What will actually we predict in future. That's all. The data you can see the column here, 200 rows and 100 columns. Next, I have to evaluate the, let's see what I have to do. Okay, I have done it. Okay, now I have to do this part. I have to evaluate the model by calculating the several metrics here. Okay, let's just copy from to percent copy. Paste. Let me just run it. For actually. By mean absolute. Okay, let me just check whether. Okay, this part here. I have to communicate. Promise to run this one here. Test close comparison. Let's just copy it and test close USD. Then I have to mean absolute error my. I have to use my. I have to use my here instead of ABC. MEC and RMC going to use RMC. Oh, I have to use MEC RMC. Okay. Let me see, let me see. And I think everything is same here. No, 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 no. Map for that. Me. I have to change it. Hope it will run. Okay, so it has run. Now let me just demonstrate here. This where this y means a mean absolute error. It measures average error in prediction actually. And this RMC here, RMC here, RMC means root means square error. It indicates how spread out the residuals are actually. Means and I have used the map forecast minus test close CST here. This map means mean absolute percentage error. Then I have plot it and print it, and the output is here. So I have print the result of this matrix to evaluate how well this anima model actually has prediction that in the future prices compared to the actual test data. So 0.35%, 0.35 I have done from here. Then I have to do this square looks fine. Okay, then I have to do the graph. Let's just copy PL, PLG plot. Hmm. I think everything is same from here. Nothing will change. But first let me run it. Okay, so it has plotted actually. So this PL.plot, I have used the chain.index here. Chain data represents actually the historical data. This data that the model was trained on, the historical data actually that the model is actually trained on. Then I have used the test.index here. Test actually represents actual values. Then I label it in the test. Then I have plotted the forecast. Forecast this represents model's prediction. Helps to visually compare the performance of animal model actually. Then I will represent this graph here. And so it's actually finished. Now I have to do the time series forecasting with profit. Okay, so let's just type in stock profit, copy, type in stock profit, run. That's how I installed the profit. After that, we must prepare a data set. Okay, so this part here, DFP, copy. Okay, it has run. In here, df dashboard be receipt. I have used this receipt method here again. This receipt the df so that the time columns here, the time columns here becomes regular column again. Time and close used to create the new data frame TFP. In this TFP data column, time here is renamed to days. The close EST is renamed to Y. This is valve column. Then I have to do the import part here. Copy. Okay, so I have used this profit here. This means that I have created an instance here. Then I have used the model.feed df underscore p. This means this model will feed the df underscore p data frame. Then I have future data set. Okay, so model.make future data frame. This means I used to create a data frame with additional future data. This is called additional future data in here, like I mentioned, 365 days, which is a period. So then I have run it and I got again another table. It generates a prediction for dates. Future dates here. This is all the future dates. Prediction.head method. This prediction.head method displays first few rows of the prediction result. Now let's model the prediction here. How the model dot prediction is that's it. Let's just copy Control V, run. Okay, the plot has created. Let me see. Yes, I think it's the same, I guess. But I have to use the component code here. Copy, paste, and just run it. Okay. Yeah, I completed the graph part here. This one. Then I have to, I guess they have to do this part here. Okay, let's just copy the code from res, copy code, control A. Okay, it has found. Then I have to do this one, copy. Here I have used cross validation method. Here I have used plot cross validation metric. And I have used this map here. This plot cross validation metric function is useful for evaluating the performance of a time series model actually. And this map here actually metric chosen for evaluating map. Map means mean absolute percentage error. So I have run it and this is the graph. I think it's the end here. But yeah, let me just go through it again. My name ID. Matplotlib, minus 200 minus 200. Next model, the scalar matrix. I printed the RMS in equal 0.35%. Then I plotted the graph here, trade, test, forecast, 5 install profit, second part, mention the columns, prediction not here, this is the table, quick, sorry, model.plot, this is the plot here, x-axis, y-axis, this is the prediction, 365 days, run, cross is the cross validation matrix, and that's it, I guess. The last one is a profile from person. I think I have, oh, I think I have to do from till here. Not sure, just okay, that's all. I'll stop the recording now. Thanks for watching.